Okay, so the first one is quota sampling. So the main things about quota sampling are that it has a fixed sample size. Okay, and that it forces the sample to be representative of the population for some variable. Okay, so example-wise, in 2007-2008, 3,879 students attended LTHS. The demographic background is shown. If you want to survey 751 current students, how many individuals of each race should you include in the sample? Okay, so we're going to look through the chart, and I gave you kind of the breakdown of the students from 2007 to 2008. So the first thing would be to find, the first step would be to find the percent of the population that's in each group. Okay, so they told you the total number of students here in the problem. And so we would just take the 237 out of 3,879 to get 0.061. Okay, so 6.1% African American. Okay, then you move on. So then you got 31 out of 3,879, so 0.008. Okay, and so you would fill in the rest of the chart. Any questions on how we're getting these numbers? 0.014. Okay, this one would be 0.786, 0.108, and then 0.023. I think actually this one got changed to 419, just so that you have accurate data. Okay. So then in step 2, we're going to multiply that percent by n, the number that we want in the sample. So it should still be, 6.1% of that 751 students. Okay, so if I do 0.061 times 751 students, I should get the sample. So you should, if you're trying to make it representative of the population, you should try to sample 46, which is what you get when you get this. Okay, 46 African American students. Okay, and so we're trying to force it to be representative of the population. If you do, yes.
Where'd you get 751?
Right here.
731 current students.
Sorry. Yeah, that's who we want to survey. 0.008 times 751 would then give you 6 Native American students. Okay, so you're kind of forcing it to be representative. 751 would be 11, and then 590, 81, 17. Okay, so total, when you add these up, what should you end up with? 751 students. Okay, but you're forcing the same to get the same percent as the population in each category in the sample. That's quota sampling. Questions? Pretty straightforward? No, sorry. Okay. Stratified sampling. It also has a fixed sample size. Okay, the population is divided into 2 or more non-overlapping subsets. Okay, each subset should be more, how should I say it, similar to each other than the population. Okay, so you're like picking people, you're grouping people based on similarity, okay, into these subsets. This is sort of like a combination of quota and simple random, bless you, and simple random sample. Okay. Okay, so to get your stratified sample, you're going to first separate the elements. There's 3 steps if you're trying to plan out how to write it. Separate the elements into different strata. Just like your groups, your subsets, okay? Second, you're going to determine how many elements come from each stratum or group. Why do I keep leaving out the R? Sorry. Or subset. Okay, and then 3, you're going to select a simple random sample from each group. It always makes more sense once you do the example. Okay, but those are the steps. So this example says an obstetrician has 156 expecting patients. 75 are expecting their first child, 54 are expecting their second child, and 27 are expecting their third child. The doctor wants to test a new painkiller on 25 women. So this is where your chart comes in. Start in row 103, use the 3rd and 4th digit of the 3rd column and move down the column. Okay, so the first thing we're going to do is kind of separate them into different strata. Okay, so here's your strata. The first one is going to be the people that are on the first kid. Okay, the second one, second kid. And the third one, third kid. Because that's how the problem sort of separated it for you. Okay, so you're trying to make the people that are in each strata more similar to each other than they are to the entire population. Okay, so how many people were on their expecting their first child? That's total, yeah, so 75. Okay, so we're going to let 0, 1 through 75 represent any of those numbers that are giving us this first kid here. Okay, we need to figure out how many people we're going to need to pull from this group of the first kid. Okay, so this is where kind of the quota sampling comes in. We want to make it pretty representative of the whole population. So we're going to take 75 out of the total. How many expecting patients? 156. Okay, times how many people do we want at the end to have tried this drug on? 25. Okay, if you want to write n equals 25 here, or underline it or something so you know where that came from. Okay, and so we need to take, that gives you 12. Okay, so we need to take 12 patients or women from this, or we need to get 12 into this stratum. Okay, so now take out your chart. There we go. Okay, here's your simple random sample chart. Okay, and what did it say to use? It said start in row 103. Okay, start in row 103 and then use the 3rd and 4th digits of the 3rd column. So is that 23? Okay, so put your finger there and move down the column. So the first one, does 23 fall between 1 and 75?
Yes.
Okay, so you would label these women that are on their first child, 1 through 75, and you're going to take the 23rd, the person who you labeled 23, then move down. So 22, is 00 in there? We didn't label anybody 00, right? Okay, so move on. 65 fall in that range? Yeah. 23 we already had, right? 93, is that in that range? Okay, 42, 31, 12. How many do I have? Anybody keeping track? 12, 27, thank you. That's 8. Okay, 46, 1, 15, 95, no. 31, I think I already did 31, right? 82, no. 36, am I at 12 yet?
Yep.
Okay, so then we stop, right? Because we only want 12 in this group. These 12 people, whoever you gave these numbers to, those women would be chosen to take the painkiller. Okay, keep your finger on that 36 so you don't lose your spot. Okay, so now how many people would we need? We need 0, 1 through 54 to represent. And you can use the same numbers because these are new people. Okay, you've started over now. So trying to make it the same color and it's not doing it for you. 0, 1 through 54. Okay, we need to figure out how many should fall in this category, so we're going to take 54 out of 156, which is the proportion of women on their second child, times 25 people that we want. So 9 women need to fall or come from this group. Okay, so we left off on 36, so I'm going to keep going from there. Is 54 a number in this group? 54, so that last person makes it in. 29, 61, no. 53, 96,
Nope.
no. 45, yeah. 16, 48, 95,
Nope.
51, 7, 55, no. 2. That's 9, right?
Yeah.
Okay. So I stopped because I only wanted 9 people in that one. Make sense? Okay, why don't you guys do the third kid one then? Start where you left off on your table.
So it's 4 women.
Yeah, I did. I was still there because I didn't home sleeping.
Yeah, I'm gonna get rid of it. Look at the number.
You do get like 4.3 something, that's 4. Okay, because we're talking about people.
Just have to remember where you left off. Are always on the same, like we just keep going down the same.
Yeah.
Yeah, so it's 14.
Just start where you left off. Don't go back up to the top. Start where you left off.
We started at 103, started at 23, we had one down. And our last number was 0, 2,
Oh, but I thought they were like completely new people, so I thought you said.
Yeah, but it's
I think our scheme was to just like keep going down, so that's why we kept going down. I mean, technically you picked random people too, but you just didn't follow what they told you to. Okay, so you should have gotten 14, 25, 19, 1. Yes?
yes. There's 2 here.
Yes or no? I hear yes, but everybody? Yes? Okay. So we get stratified sampling. Okay, flip it over. Last one here. Okay, cluster sampling.
It's a lot of homework. Because if there is, why?
Okay, these are non-overlapping, sampling units are non-overlapping subsets. Okay, they may vary in size. You have to have at least one element in them. Okay, it can't be nothing. These are also called clusters, which is why it's called cluster sampling. Okay, a frame is the complete list of clusters or your sampling units. Okay, when you write all of them out, that's your frame. Okay, your sample is a group of clusters selected from the frame. Okay, so the way I always think about this one is like you're selecting the whole group, not people out of the group. Okay, you got to take the whole group if that group gets selected. Okay, it is not a fixed sample size. Although you do have a minimum requirement. Okay, so someplace in the problem they'll tell you like you must have at least this many people. Okay, but there's not an actual fixed sample size. Or not people, if you're talking about something besides people, whatever you're sampling. Okay, then we're going to use a simple random sample of the clusters, not the individuals, which is what makes this different than stratified sampling. Okay, so in stratified we did group them, but then we used a simple random sample and just picked certain elements out of that group. In this one, once you group them, if that group's number gets selected, the whole group goes. Okay, so that's the difference here, because people always get these confused on the test, these two. Okay, you may want to study the effects, or you want to study the effects of detentions have on decreasing tardiness. You need a sample of at least 48 students. Okay, and I'm going to give you your frame. I'm just going to give you some teachers here. Grath has 27 students. Samulus has 32 students. We have, I think it's 25. We're going to go with 25. Okay. Lorick has 29 students. Waichert is 31 students. Okay. How we're grouping. Okay, first step would be to label the clusters. Okay, so step one, label each cluster. So I'm going to go through 1, 2, 3, 4, 5, 6. Okay, labeled the clusters. Okay, step two, determine how many clusters you need to meet the minimum requirement. Okay, so if I need at least 48 students, can I only choose one cluster? Do you think I need to choose more than 2 clusters? No, I should hit 48, right? If I choose any 2 on here, I should end up with 48. Okay, so it's set up that way. So I only need 2 in this case. Oh, it says at least 48, so it doesn't have to be exactly 48. Yeah, that would be real easy, right? You only have one option. No, at least 48. So, okay, then you're going to use some simple random sample scheme. Okay, and I'll give this to you. So go to your chart and use row 128 and just start at the beginning. Okay, so if you go to row 128, what's the first number you got? 4. Okay, so our sample is going to be made up of 4, and then just go straight across. 2. Okay, so 4 and 2. So Lork's students get put in, and Samuelis' students get put in the sample. Okay, so then you could figure out how many people are in this sample by adding up their students. 29, 32, so what's that, 61 students. Okay, but do you see how it wasn't a fixed sample size? Because you don't know how many you're going to end up with until your clusters get chosen. And do you also see how I didn't label the students in each of those classes and then only pick certain students out of the class? The whole class got taken. Yes?
Yeah.
Okay. There is something called convenience sampling. It's not real representative, so I'll just explain it to you. It just consists only of elements available to you. So like if this would be an example, like if I wanted to sample the seniors in the school, and then I was like, I'll just take all of you guys and get your opinions because I see you every day. Okay, something that's super easy. Or if we wanted like student opinions and then we just like stood in the cafeteria and just like grabbed a couple kids. Okay, there's nothing representative necessarily about those people. It's just easy. That's why it's called convenience. Okay, and then a census measures a variable for every element in the population. So you're not choosing certain people to sample, you're just taking everybody. Okay? Oh, that's already. Okay, you guys are done. So, yes, there's homework. It's on your assignment calendar. Once again, you only have to do the odds unless it otherwise says so. Okay, so there's not a ton of problems today. I'll hang up the answer key. I'm assuming that we're a little behind on our homework right now because of doing the test, making up the test. So get going on that over the weekend if you have time.